Now we're going to transition into the quantitative part of solutions. And I want to start by showing you these 3 batches of Kool-Aid. Tropical fruit punch, yum. Notice they're all homogeneous solutions. I can see through all of them, and they're all unsaturated. How do I know that? Well, there's not stuff at the bottom. There's not crunchy Kool-Aid. I made my Kool-Aid right. Some of you don't make your Kool-Aid right. Some of you make crunchy Kool-Aid, which means you can't dissolve all the sugar in because you put so much stuff in it. If you were here, we'd have a lively conversation about that. Now, what's different about these 3 tropical punch Kool-Aids? Well, you could see I put more, as I go this way, I put more powder in. So what can we say about that? What word do we use in regular everyday life? We use the word concentration. This is way more concentrated. What does that mean? I put more crap in the same amount of water, right? Not a lot. Put some more in. Put a lot more in. So this one is more concentrated. And we're going to start talking about how we measure concentration as a chemist. In this lesson, we are going to learn how to calculate the concentration of a solution. So we're in the quantitative part of solutions. And remember, we need to measure how concentrated a solution is, how much stuff is dissolved in that solution, and we call that molarity. Molarity, with the capital M, is moles, you already saw that little n from your gas unit, divided by liters of solution. So this is important to know that this is liters of solution, and this is moles of solute. Okay, so basically we're just going to use this formula right now. We're going to manipulate it around. We're going to solve for the different variables. 5 moles are dissolved in 2.5 liters. What's the molarity? Well, I just take moles divided by liters. Moles divided by liters, and I get 2.0 molar solution. So you could say 2.0 molarity, 2.0 molar solution, or 2.0 moles per liter, which is your actual units. But remember, chemists are lazy, so we just made a capital M for molarity. So now what if I don't have moles? What if I have grams of sodium chloride are dissolved in 0.5 liters? Then what's the molarity? Well, I have to convert grams to moles using the molar mass from the periodic table. And then I get 1.98 moles of sodium chloride, and this is moles divided by liters is molarity. That's what I've done, divided by 0.5, and I get 3.96 molarity, or 3.96 molar solution. Okay, you guys should be trying these problems on your own and see if you can do them. We're not going to do too many of them, so practice with me. 10.0 liters of a 5 molar solution of sodium chloride contains how many moles? Well, moles is in our formula, okay? Or you can actually see that you can just use dimensional analysis here, but when I rearrange the formula, it's molarity times liters equals moles. This is an important concept because if I know how many moles are in something, I can use stoichiometry. You're going to use this in your dilution equation. So I take my 5 moles per liter, which is my molarity, times my 10 liters, molarity times liters, and I get 50 moles of sodium chloride. Or they could have asked how many grams. If they want to know grams and you know moles, you can take that 5 moles and you can convert it to grams, right? Moles times molar mass is how many grams are in that solution, and we get a whopping 2,900 grams. So they could ask you for moles, or they could ask you for grams, and then you have to know to solve for moles and then go to grams. Okay, so you are going to do a molarity lab, and I like to do it with Kool-Aid instead of copper sulfate because, first of all, like I said, for some reason high schoolers don't know how to make Kool-Aid, so I kind of want to teach you the right way, and it's way more fun to make this solution than to make copper sulfate, which you can't drink. Okay, so You are going to make several different molar solutions of Kool-Aid, so you need to figure out how many grams to put in 50 milliliters. So how many grams of sugar are needed to make 50 milliliters of a 2 molar solution. So I have my milliliters, I have my volume, and I have my molar solution. So the first thing we need to know is molarity is moles per liter. So I have to convert milliliters to liters to get there. Okay, so I get 0.5 liters, and then I need to find the moles of sugar needed. When I rearrange my molarity equation, I get molarity times liters equal number of moles. My molarity is 2.0, my liters 0.5, that gives me 0.1 moles of sugar. And then how many grams of sugar am I adding? Well, once I know moles, I can convert it to grams, and the molar mass of sugar is 342. So 1.1 mole times 342 gives me 34.2 grams of sugar. And you're going to make 3 different molar solutions. You're going to first calculate the moles in a chart and then grams, so you'll know how much to add to that 50 milliliters.